What is RFID? RFID is radio frequency identification, and it's basically the wireless transfer of information through radio waves. Before this, we had barcoding, and barcoding works the same way as RFID. There's a tag or a label with information on it, and then we have a reader, and that reader reads the information on the tag or label, and it's transmitted into a computer, and the information absorbs, and from there we go through a checkout or whatever we need it to do. RFID works exactly the same way. Instead of having a label with a barcode on it, we have an antenna with a tag, and on this tag is a microchip, and on this microchip is stored information same as a barcode. This information is then transferred to a receiver, which is sending signals asking the information of what's on a tag. So once the data is absorbed, it gets transmitted into a cash register or database the exact same way. The difference between the two is that with a barcode, there's not a lot of information that can be written on barcodes as much as an RFID tag. RFID tags can store a vast amount of information, anywhere from shipping labels to access control to even biometric security information. So why would we want to use this? For one, RFID is wireless. We don't need line of sight like we do with barcoding. Another reason is that it's fairly environmentally friendly. Labels use nothing but trees for paper. RFID, there's alternate methods of creating tags. So what is an RFID tag, and what does it consist of? There's a few parts of it that are crucial in all RFID tags. The first being the chip. The chip has a lot of different parts to it. The first part, of course, is that it stores information, anywhere from an inventory tracking number to a database number or a user ID. This chip also contains the transmitter and receiver for the wireless signal. When a receiver hits the RFID tag with radio waves, it excites the tag and in turn activates the chip. The chip then sends its information back to the transmitter and thus into a computer of sorts. The next part of the RFID is the antenna. Nothing would work without the antenna. The antenna is one of the most important parts. This determines things such as how far away the tag can send its data and how accurately it can send the data as well. The antenna is usually wrapped around the tag in multiple coils to enhance the signal. The final part is that it needs some sort of medium for all this to be on. There's various types of tags. Some are circular, some are square, some are filmy, very loose. Some have an adhesive backing, so they can be placed on products or packages. Some even are hard, and they can be used as identification tags. They can even be printed with picture IDs or words or anything else you can think of. There are three types of tags that are currently being used. LF tags, low frequency. HF tags, high frequency tags. And UHF, ultra high frequency tags. Each one of these tags has its own purpose, but they all work the same throughout. The only difference is the radio frequency at which they operate. LF is a lower frequency, HF is slightly higher, ultra high is very high, in the gigahertz range. LF tags can be used in a short range operation. HF tags can be used in a medium operation, and UHF can be run at long range operation. In order for these tags to work, they need a reader or an antenna. A reader basically consists of nothing more than an antenna connected to some sort of device, which is then connected through a communications cable, in this case serial, which is then connected to a computer, and from there the information is extracted. It's very important to note that for the reader to work, we need software, also called middleware. And this middleware basically tells the reader to go out and search for a tag, or to do different functions, to either loop or put information in a database or what have you. This RFID reader was made by a company called Seret. This is an industrial strength, ultra high frequency RFID reader. It basically uses ultra high frequencies to read and write to tags. This reader is very powerful and has an extremely large read range. It can read at very great distances. As well as it having a very large read range, it's very powerful so that it can read and write tags with other objects that might be interfering with the signal, so it can still get a good solid read of tags. This RFID reader is made by a company called Jet, and its main purpose is for mobility without being attached to a desktop computer. The RFID reader is an all-in-one unit. It consists of a keyboard, a screen, and the RFID module antenna in the back. It also supports an expansion slot for devices such as Bluetooth or Wi-Fi. Another great aspect of this product is that it's readily available for programming. Any user can create their own code and upload it to the device. This device supports languages such as C, C++, and VB, Visual Basic. There's a lot of different applications that this device can be used for, and coding your own can be very valuable. This device supports the expansion of a wireless card, so you can put this device on a network. So for example, you can make your own code for your own application, go to a tag, absorb the information, and through your code that you made, you can have that information automatically be parsed and sent directly to a database that's on the network through the wireless card. And through these types of applications, we can expand this type of reader to do endless possibilities. So what we have here is a smaller RFID reader. This is actually called a fidget RFID reader, and it's catered towards home and personal use. As you can see, it's a relatively small reader. It's got a small antenna. It's not terribly powerful, but as you can see, it has a USB cable, so just about anybody with a normal computer can connect to it. It's very easy to use. The middleware is open source, and you can actually write your own code for it to do certain tasks. The reader here, it comes with its own software that reads tags and reads information, but the code you can add you can tell this board to do more things. For instance, there's a LED light on the board that can light up when you read a tag successfully. There's also a 5-volt out, which can be used to control an external device. For example, there was a guy that made software that interfaces with this using Visual Basic. And what this software does is once a tag is read, if that tag is authorized through a database that he made, a 5 volts will be transmitted out, which will be then connected to a door or to a motor, which in turn will unlock a door. So what we have here is an RFID accessed door. So this is an application for the fidget RFID reader. And what we're doing here is we're using it for door access. What, as you saw before, was I waved
my RFID key in front of the door, which then triggered the RFID reader, which then sent a signal to the computer, which then allowed me to access the door. The way that it worked was, this reader is connected to a computer. On the computer is a program that runs the reader and controls it. Also, there's a program on there that has a database, and in this database stores the information of the tags. And what I did was I added myself into this database and granted myself access to the store. So basically what happens is, when I waved my RFID key in front of it, the database says that I'm authorized to access the store. The computer then sent a signal to the relay, to the buzzer to acknowledge that the door has been unlocked, and then finally to the actual door mechanism to unlock the door. And there I have full access to get into the door. What's very nifty about this program is that it allows multiple users with multiple RFID keys, and it also allows date and time constrictions. So I can set up a user to access this door from 9 to 10 in the morning, Monday through Friday, and the rest of the time they're blocked out and they won't have access to the store. All I got.
RFID tags can store a vast amount of information, anywhere from shipping labels to access control to even biometric security information. So why would we want to use this? For one, RFID is wireless. We don't need line of sight like we do with barcoding. Another reason is that it's fairly environmentally friendly. Labels reads the information on the tag or label, and it's transmitted into a computer, and the information absorbs, and from there we go through a checkout or whatever we need it to do. RFID works exactly the same way. Instead of having a label with a barcode on it, we have an antenna with a tag, and on this tag is a microchip, and on this microchip is stored information same as a barcode. This information is then transferred to a receiver, which is sending signals asking the information of what's on a tag. So once the data is absorbed, it gets transmitted into a cash register or database exact same way. The difference between the two is that with a barcode, there's not a lot of information that can be written on barcodes as much as an RFID tag. What is RFID? RFID is radio frequency identification, and it's basically the wireless transfer of information through radio waves. Before this, we had barcoding, and barcoding works the same way as RFID. There's a tag or a label with information on it, and then we have a reader, and that reader